Let's now talk about the key methods that are part of the countdown latch. It has a very simple API. There's just a handful of methods that are commonly used. The constructor is used to initialize the count. No surprise there. It's given a count parameter. And under the hood, it simply creates a new instance of the abstract queued synchronizer with the count passed in to indicate the initial count. Note that this count cannot be reset without making a new instance of the countdown latch. That's why this only works for one-shot barrier synchronizers, not cyclic barrier synchronizers. The two key methods, or the two types of methods it has, count down and wait for the count to reach 0. So those are the two things that you can do. Under the hood, all these methods just forward on to the abstract queued synchronizer framework methods that handle all the heavy lifting of how things work. When you call the await method, that causes the calling thread to block until the count reaches 0. So when you call await, if the count is greater than 0, it'll block. And when the count reaches 0, or if the count is 0, then it'll go ahead and proceed. But you can have that thread be interrupted. There's also a wait variant that will wait up to a certain amount of time for the count to reach 0. And if it is not, if it's interrupted or if the timeout elapses, it'll return early. And it's interesting to note that there's no non-interruptible version of await. So everything can be interrupted. Decrement will, or sorry, countdown will decrement the count of the countdown latch by 1 using the abstract queued synchronizer framework. And when the count reaches 0, that then causes everybody to wake up. So that's used basically as a signal to indicate that anybody waiting for the latch to be open can now proceed. So it's used to release the waiting threads. The threads that call countdown don't block. Threads that call await may block if the count is greater than 0. When you call countdown, it just decrements the count. You keep going, and if the count has reached 0, then anybody who's waiting will go ahead and be released. OK, so those are the methods. I think you'll agree that that's pretty darn simple. So there's not a whole lot to think about in terms of the mechanism, which is why this is a very useful barrier synchronizer if you have a simple use case. As we'll see, if you have a more complicated use case, it's not going to work very well. So that's why there's these other mechanisms.